Welcome back. This is the most interesting section of this course, and I plan to cover test-driven development and refactoring in this video. What is test-driven development? The internet has many definitions. Basically, your test will drive the development of a feature. Why do we do it? Again, go through my course notes and a couple of blogs to get the idea. You'll also see why we do it in a moment, but in my opinion, the biggest advantage of test-driven development is that you would have tests to begin with. You can always write tests after you code out the feature to log the requirements, but we never find time for that, do we? Now, I am no testing expert, nor do I always use test driven development. I use it maybe 10 to 15% of the time when I know my requirements are pretty straightforward or when I discover bugs that could creep in again in the future. With time and practice, you'll also learn when to use and when not to use it. I'm still learning, but do not let someone on the internet tell you that this is something you should always do. Find the right trade off. I would also suggest doing test driven development as part of a pair coding session. This way, one codes the actual feature while other figures out the tests, saving quite a bit of time. Either way, let us look at how we can use test driven development in our simple to do application. Now, if we open our application, we can see a couple of things that we can fix. First up, when we type into the input field and click on the add button, the input field doesn't clear. Next thing, if I click on add button, an empty task is being added to our list. Next up is if I try to press enter, I'm not able to add a task to my list. Ideally, that's a good to have feature. So let us fix these issues by following a test driven development approach. Since the requirements are pretty straightforward, it's easy to convert them into tests first. Let us first try to write down our test descriptions, like maybe our names, like test names. So I'm going to do something called test.todo. This indicates that this is a test to be completed in the future, like it's a to do, right? So first test is to clear the input field after adding a task. Next up was our app should not add an empty task. Should not add an empty task. And the third test requirement was it should add a task by pressing the enter key. Cool. Now that we have our three tests, let's see what happens if we run a test now. So let me open a new terminal and run my test. You would immediately see that we have our three tests that are passing. Oh yeah, we had one in our sum. That's why we are seeing three. But the actual app had two passing, only two. And we have three pending tests, which is our to-do tests. Let's implement the first test. What should we do? The user has to type into the input field, click on the add button, and then we have to assert that the input field is cleared. So similar to our previous test, we would need a user, which we are getting it from user event. Next, we should have a isolated test. So we are going to render our app again. Since we did a cleanup, we are going to clean up all the previous instances of the app. I would still need to capture my input M button, which I'm going to just grab from my previous tests. Again, I can pretty much use the type and the click events from the previous test. Next, I'm going to await and wait for, right? The user has clicked the button. I'm going to just expect my input now to be empty. So we have something called to have value, and that can be empty. And since this is a user event, we know that the test is asynchronous. Cool. Now that we have a test, let us remove the to do and see that we have a failing test. Great. So our test is failing. That is the respective test that is failing, I believe. Yes, should clear the input field after adding a task. Of course, this is going to fail because we did not write the respective feature code. Now, you could go ahead and write the test for the rest of the pending test, but I prefer to do one test at a time. So let's go fix this feature first. Back in our app.tsx, when we click on our button, right? When we click on the add task, we know that we should clear our input, which is nothing but the task name. So all I'm going to do is set my task name back to an empty string. And I'm going to save my file. And you see that my test now passes. And we can also verify it by click on my add. The input field does clear. Cool. in a nutshell, this is what test-driven development is. Test first, then you code your feature out. Here our requirement was pretty simple, so it's easy to write test. In fact, you could have not written a test and added this feature, but this is nice. It helps when you're refactoring, which we'll see soon. Let us implement the second test. What should we do? When we click on the add button, when the input field is empty, it should not add a task to our list. So we should assert that the task is not added to the list of tasks when it is empty. Most of the logic would remain same, and it's fine. You can do this bit of duplication. Since we are testing for empty tasks, I want to also capture two more bugs, potential bugs, which is white space. So I'm going to just cover white space and empty task in one particular test. You could have a different test for that if you want to, but I'm just going to cover them at once. And we are going to still await and wait for our task for our user events to complete. And now I expect my screen. I'm going to use the screen since I want to capture the list item. And I'm going to query all by role. And what we are looking for is a list item. Again, there could be multiple list items. Here I know there's only one list in my application. So make sure you find the right query for that in case you have multiple list items from distinct lists. And I want this to have a length of 0. Right? And again, this is an async test. Cool. Now let us remove our to do. And we should have a failing test. Yeah, should not add an empty task. And we see that expected to have a length of 0 but got 2. We are getting 2 because we have a default list item already present in our screen. So let us also remove that. So let us remove this. Now we would see that it has one item, right? So let us check how we can do this. So before we add a task, I'm going to just grab a variable, create a variable to trim my task name. I'm calling it trimmed task name. And if this is not defined, right, I'm going to just return. And wherever I was adding my task name, this is now going to be our trimmed task name. Let us save and see if that passes our test. Cool. And let's also try it out manually. Perfect. I'm not able to add any task. Let's test for white space. Yep, even that doesn't work. I also want to add a quick call out. Sometimes people disable these add buttons when the input field is empty. There's a lot of debate around whether it's a good practice or not. I personally agree that it's a bad practice to disable buttons. It's kind of out of scope of this tutorial to discuss that, but I would suggest going through my course notes and looking for this particular article from Adam Silver to better understand why. I will also attach this in the description, but I'm just letting you know that disabling the buttons is not a good idea, according to me at least. Cool. Coming to our final test, which is should add a task by pressing the enter key. So how could we do this? Type into the input field, press the enter key, and then assert that the task has been added. Again, we're gonna do the same setup, which is const user event.setup and render our application. And we should also be getting our input. Next, we're gonna use the user.type method, similarly as we did for previous inputs. But this time, we're gonna use a special characters to do this to indicate the press of enter key, which we can do with curly braces. I'm giving a space, maybe you could also remove that. Right. And now we're gonna await and wait for our screen, query all by role. And again, I'm gonna just check for my list items. And this to have length of 1. I'm using to have length. You could also check by text, like check whether new task has been added. Either works. Maybe that might be a better solution, but I feel like this is also good since I know that my tests are isolated. Again, this is asynchronous and this should fail. Oh yeah, this is to do. So just remove that and this should fail. Yeah, this fails. And let's confirm that this is the test that fails. Should add a task by pressing the enter key. Yeah, cool. Now let us go and add this feature out. And the simplest way to do this is actually to put our input and the button inside a form element. but I'm going to do that in the refactoring section. So right now we're going to use the old fashioned method of using on key down, and we're going to get a key. And if the key is enter, we're going to just basically on add task. Let us save and check. Yes, there you go. Our test passes. Our requirements are good. Most of our functionality should also work. Let me try it. I'm going to press enter now. It works. Enter on empty task doesn't work. Maybe this way of having an inline function is generally not a good idea. So let us abstract that out into its own function. So I'm going to call this on input key down. And I can also show you how TypeScript works over here. So I'm going to just copy this part here. Maybe we can improve the curly braces. Now, what is E over here, right? So E is basically a keyboard event from React. So you can ideally figure out what is the exact type you have to give over here. I know this from experience. So it's react.keyboard event. And what type of event element it is? It's an input element. And I'm going to just pass this over here. Now let's just save and verify that our test still passes. Great. So this way we did a slight refactoring, and since we had a passing test earlier, we know that nothing broke. So this is again power of having tests. So you could see how test-driven development is helping us, but you'll see the actual help in the next section, which we are going to do now, which is the refactoring. Our code is kind of clumsy, so we're going to clean up a lot of things, and we'll see how having those tests will help verify that our refactoring did not lose out on any functionality. Great. We are now in the refactoring section. Refactoring is important irrespective of whether you have tests or not. You should always find ways to improve the design of your code, make it more readable, maybe clear out some of the technical debt. In fact, the first few lines of code you write are usually not the best, and it's best to refactor once you know there is a better approach. Now, of course, the topic of refactoring is huge. There are entire books written on it. We just covered the bare minimum here. So I would always say look out for good blog articles to improve on testing and refactoring in general. If you look at our current app.tsx file, there's a lot of code, around 53 lines of code. Not bad, but we could drastically bring this down. Right away, I know a couple of things I would move away, which is the types. We can have a separate file or folder where we store these types, right? So I'm going to create a types.ts file and move my types over there. And I'm going to export the task type since I'm using it in my app. We have already reduced it by around 9 lines or something. Now, maybe we could also extract the input and the label into its own component. You could call it something like task input component. So I'm going to create a task input file and basically move my label and input into that component. So it's going to be a export default function task input and return. I'm going to use a fragment since it has a label and input. We need a couple of props to be passed from the parent, which is the app, right? So let us define this first. So I'm going to call this task input props. What are we taking? We are taking a task name, which is string. Then there's a set task name, which takes a task name as a string, and it's going to be a void. Next up, we have on input key down. And this we know it's a react.keyboard event. And this is HTML input element. And this will also return a void. Return nothing, which means return void. Now let us tell our component to use these types, these types for props. We have our task name, we have a set task name, and on input key down. Great. Our task input is happy. Let us use this task input component in our app. Great. Let us pass the required props, which is the task name. Next up is the set task name and also our input key down. Now you see that this is not a huge improvement. Our lines have not reduced. We just abstracted, but it pretty much added the same amount of lines again. But maybe we could also move our button into the task input itself. So let us try to do that. So I'm going to move my button also into my task input and also pass the on add task as a prop. So let me also define this. This pretty much takes nothing and it just calls it. So it's going to be an empty params and void on at task. Good. So, and we can also pass the on at task function over here. Great. Maybe we reduced by 2 lines or something. Maybe we could also now refactor our task input name. We're also worrying about file names right now. Task input just sounds like an input. But right now we also have a button over there. So it's a good idea to call this something as maybe add task or task input with button. Add task seems reasonable to me. And I'm going to also rename the actual function export. Right. And I'm going to also call this as add task and clean up my inputs. Now, you see this on input key down. This is not used anywhere else. And maybe we can move this into our add task component and avoid passing that prop down from the parent. So I'm going to clean up that import. So now you see that our app file has reduced quite a bit now. It's around 40 lines now. And we also reduced the amount of props we pass. I want to show a little performance problem. It's not a huge problem, but I'm going to show unnecessary renders over here. Let us put a simple console log at the top. I'm going to just call it console.log app rendered, right? And open my console. Now, whenever I type in my input, you would see that that the app has rendered. This seems unnecessary. Why does the whole app have to render when I'm typing into the input field? This has to do something with where our state is located. You see our task name, which the input manipulates, is located at the app level. And ideally, we don't have to use it here. We could bring this state down into our add task component. Let us do that. And this way I don't have to pass my task name and set task name to the component, right? And I'm going to import React since we're using React over here. And I'm going to also clean up this. But our on add task is still in the parent, right? And it still needs the task name. So what we could do is you could pass it as an argument. So this is going to be a string. And you see that there's a set task name which we are doing it. So right away, let's remove it and you'll see how our test will help us capture this later or missing functionality. And now we know there's a type mismatch. Or add task takes a parameter which is task name. So now on add task, all we have to do is pass our task name. And here where we are on click of button 2, we could pass our task name. Great. Now if you save, there would still be one particular test which is failing. We are not clearing our input field. And this happened because I was refactoring quite a bit of code. You could also be doing something like that and miss out on that particular requirement. So having tests will help catch such bugs, right? So let us bring that functionality down. And I don't like this two different pieces of functions doing the same stuff, like adding tasks. So I'm going to abstract that out. I'm going to have something like const handle add task, which will handle the addition of tasks to the list. And I'm going to basically bring all the logic which was streaming my task and adding it. And here I could just pass it as task name. And I'm going to bring this down to my handle add task. And I'm going to still call the on add task. And this time I'm going to pass in the trim task name directly and set my task name back to empty string. So here where I was doing a on input key down, I'm going to just do handle add task. And at the bottom too, where I was clicking on the button, I'm going to just call this function right now. Great. Now our test should pass. And let us also save the app file so we're not losing on anything. Now, if you try to type in the input field, you would see that our app doesn't render anymore. So this is a good way of solving certain performance problems without using fancy stuff like use callback or use memos. In fact, those things will not help here. Just bringing down our state helped us greatly over here. Now, I'm going to remove this console and I'm going to show one more improvement which we can do. This is again part of refactoring. I don't like this logic where I'm handling the input key down when the browser gives us this functionality by default. And in order to enable that, all we have to do is have a form element. And we could remove this key down logic. And I'm I can also remove this on click on the button and let it be an add button. Would submit a event. So on submit, it's going to be handle add task. Now our form handle add task will take a event. We'll take a parameter event, which is the react.form event. And we know that it's a HTML form element. And one thing which we need to do is do a e.prevent.default. So usually forms, when you click on submit, they refresh the page. We want to avoid that. That's the reason we are doing e.prevent.default. So E is the short form for event, right? It's a form event. And now if we save, our tests are still passing and we still have a functionality of adding a task on press of enter, and empty task won't work. Now, if you look at our code, the app.tsx is quite small, around 30 lines. Pretty simple code to read, better than previous code. Our add task component is handling everything related to adding a task. This was a very simple example of refactoring. Imagine doing this on a larger code base and improving it drastically. We also saw how we were able to solve a small performance problem. Even though it is small in this case, I use that particular logic everywhere, and it greatly helps simplify things from a readability perspective also. Now let us save our code. I'm gonna call it test and refactor. See you in the next section.